Assalamualaikum and hi, my name is Alif bin HAMIDIN. My student ID is 2021206878 and I'm from class F1.
Hi, Assalamualaikum. My name is BALQIS binti KHAIRUNNIZAM. My student ID is 2021623468 and I'm from class F1.
Hello and Assalamualaikum. My name is ZIKRY bin DZULKHAIZAM. I am from F1. My matric number is 2021848736.
Hello, Assalamualaikum. My name is HASNAAIN YUSMA. I am from class F1. Matric number 2021209888.
So today group 2 will be presenting about the application of differentiation. So the two main subtopics that we will be discussing are related rates and applied maximum and minimum problems.
So related rate is one of the application of differentiation in fundamental theorem of calculus. Related rate are normally involving figure out a rate changing of a quantity from another quantity that is given sufficient information. And the related rate is known for its benefit in application in our life. Next, why do we use related rate? The reason is because science and engineering field often relate quantities to each other. The method of related rate have broad application in this field. The related rate ensure a differentiation with respect to time or one of the other variable require application of chain rule, since most problems involve several variables. Some example of problem involving related rate in our life is determining the speed, distance and acceleration in physics. Also, amount of material used in building, factory and more. Lastly, we are using a related rate in profit and loss in business.
So this is the example for the related rates topic. So let's take a look at this example. The volume of water in a cylinder jar is given by V equals to 1 over 3 pi times with 36x squared minus x cubed. Given x is the depth of the water if water is poured at rate of 8 cm squared per second. At what rate is the level rising when the depth is 6 cm? So based on this question, the question wants we to find the level rising of the water. So how do we solve this question? First of all, we have dv over dt equals to 8, which is in this question, this one. And then we want to find the dx over dt, which is the level rising of the water. Okay, next we have the equation v equals to 1 over 3 pi times with 36x squared minus x cubed. So first step is we have to differentiate this equation first. We differentiate and then it will be 24x minus x squared pi. Okay, and then we substitute value of x into this equation. So it will become this, x equals to 6, and then we substitute into this equation and we will get dv over dx equals to 108 pi. Okay, since we want to find dx over dt, so what we can do is dx over dt equals to dx over dv times with dv over dt. So we only have dv over dx, which is 108 pi. So how do we get dx over dt? How do we get dx over dv? So we just need to terbalikkan this one because this is actually 108 pi over 1. So when we terbalik dx over dv, it will be 1 per 108 pi. So times with dV over dt equals to 8, and we'll get the final answer is 2 equals to 27 pi.
I would like to talk about the intro of applied maximum and minimum problems. Many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such function will determine the domain from which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value. The extreme value theorem, the first derivative test or the second derivative test. The process of finding maximum or minimum values is called optimization. We are trying to do things like maximize the profit in a company, or minimize the cost, or find the least amount of material to make a particular object. Many students find these problems intimidating because they are word problems and because there does not appear to be a pattern to these problems. These are very important in the world of industry.
So this is an example for the question regarding applied maximum and minimum problems, which is, let me read the question. Razali wants to decorate 2 of the walls in his room by using a luxury wallpaper. Before that, he was told by his dad that the total length of the 2 walls is 30 meters, which means the total length by this part and this part, which is represented by X and Y. Continue the question. The price of the wallpaper is 200 ringgit per square meter. Razali has a budget of Rm 800 ringgit. Does Razali have enough money to cover the maximum total area of the walls? So from the question we can see there's 2 key information that we can see, which is the total length of the wall, which is 30 meter, and the wallpaper, which is in meter square, which means the area of the two walls. So we continue with those information, so we can get the total perimeter and the total area of the walls. To get the total perimeter of the wall, we first need to use the equation that we can make, which is from the question 30, and we get 3x plus 4y. We get 3x from this 1, 2, and 3, so we get 3x, and 1, 2, 3, 4, which is y, so 4y. So after getting the equation, we can simplify by getting y equals to 30 minus 3x per 4. Then we find the total area of the walls, which is area which is symbolizes by A equals to xy plus xy. With that we will get 2xy. So the area of one of the wall is xy, so x times y, we get xy, and the other is xy, which is the same, so xy, so 2xy. So we can continue the equation, and we can also substitute in y with the equation we get for the total perimeter, so that we get 15x minus 3x squared per over 2. So the main question for the main question that is given is, does Razali have enough money to cover the maximum total area? So to find the maximum total area, we must first find the maximum values of x and y. So how to get the maximum value of x and y? So from this formula, we need to differentiate this formula to get the value, which is by let me show you. So A prime, so 15x to differentiate 15x, so x is power by 1, so we minus by 1, and for 3x squared, over 2, how to differentiate. So the value of 2 we need to bring in front, so there's 2 in front of here, and the 2 will be minus by 1, so 2 and 2, so we can cut both of them, so we will get 15 and x power x1 minus 1 is x power of 0, x power 0 is 1, and so 3, so 2 is cancels out each other, so 2 minus 1, so we get 3x. We will only get 3x. So this is the equation after we differentiate it. So to get maximum point, we need to make the equation equal to 0. So then we simplify, we get x equals to 5. So this is the maximum value for the length of x. And to get the value of 5, we use the equation we got from the parameter, and we substitute in x with 5. And then we can find the maximum total area, which is length divided by height. So the maximum total area just now we got is A equals to 2xy, so we just substitute in x and y, so we get 37.5 meters square. So finally the question asks, does Razali have enough money to buy the wallpaper? So for the price, we can just because the question gave that the wallpaper is 200 ringgit per meter square. So we can just time the total area with 20 ringgits, and then we get 750, which shows that Razali have enough money to buy the wallpaper.
The conclusion is the example question involving related rates is able to be solved using chain rule method and is also able to solve other problems that is related to our daily life. And then finding the maximum and minimum, both absolute and relative, of various functions represents an important class of problems solved by use of differential calculus. Last but not least, this is our reference. So each one of us refers to those links to study about related rates and maximum and minimum point, and also we refers to all these links to create our question. So I think that's all from our group. Thank you.